All right.
Whoa.
Rodrigo has a rectangular kiddie pool that holds 350 liters of water.
You know, I'm going to get the Rodrigo.
Jude has a kiddie pool that has inside measurements of 6 decimeters, 2 decimeters, and 16 decimeters. Which pool holds more water? All right, so what do we know? What? Okay, Rodrigo's holds 350.
We know the dimensions of Jude.
Okay, so can we find his volume?
Yeah.
Okay, what do we do to find the volume?
6 times 2 times 16.
Okay, 6 decimeters times 2 decimeters. Gives us,
112.
no,
Rodrigo.
192
192. What are our units?
decimeters squared.
Cubed. How many liters is this?
192.
192. Because remember, 1 cubic decimeter is equivalent to 1 liter. So, who holds more? Rodrigo holds more. All right, a cardboard box has dimensions 1 meter by 5 decimeters by 40 centimeters. Make a drawing of this box. So, what do you notice about the dimensions? They're different. Is it easy for us to draw the box if we have different dimensions?
No.
Okay, so what should we do?
Convert. Change.
All right, convert them, change them. What do you want to change them to?
Centimeters.
Why centimeters? You don't know?
Decimeters.
Because they're small. Because they're small? All right, so 1 meter equals how many centimeters? 100 centimeters. 5 decimeters equals how many centimeters? 50. And then we have 40. So now we could probably make a... All right, so we have 40 by 50 by 100. All right, B asks us to determine its volume in cubic centimeters. Can we do that? We have all the dimensions? And what units do we have it in right now? Centimeters. So it'll be pretty easy. All right, so we find volume by doing what?
Base times height.
Base times height. What are the dimensions of the base?
15.
Does it really matter on a rectangular prism? No. But we can do 40 and 50 if you want. And then our height would be what? 100. So 40 times 50 times 100 gives us 200,000. What are our units? Centimeters cubed. Very nice. All right, now we get to have more fun with counting wholes and partials. The city of Tulsa in Oklahoma draws its water from Keystone Lake, which is pictured below. The average depth of the lake is 40 meters, and the population of Tulsa is 624,000. So we have a drawing. We have a scale here for us too. It asks us to estimate the volume of the water in the lake and describe, we'll see how we do this together, so we don't really need to describe it. What's the first thing we should do? How are we going to count the squares? Okay. My suggestion, flip it over, trace it on the graph paper on the back.
How do you trace it?
How do you trace it?
look very carefully or make the.
Will you trace it through it?
I'm looking on.
I got it.
Girls.
I don't get it. Try to make it go like this. Do it like
I'll go through this.
Let's go ahead, grab it. Good job, Abby. Could have just grabbed it.
There.
How'd you do that?
Okay, darken the front so they can come through on the back. All right, so yesterday, what was the first thing that we did?
We counted the full blocks.
Actually, before that.
Oh, how long one was? Yeah. So
Okay.
one by one.
1 centimeter.
So, area of 1 square.
1 centimeter.
Look on the front.
1 can.
Okay, so 1 square wide is a kilometer. So how tall is it? So that means that the area of the square is 1 kilometer squared. All right, what was the second thing that we did? Count the whole squares. All right, so count your whole squares.
I got 28. I got 32. I got 30.
I have 30. All right, so we're estimating, right? So we're not all going to be exactly the same, but we're going to be close. So we're ranging like from 27 to 33. So write down the number that you found. I found 30. What's the next step that we did?
Ones and divided by 2.
Okay, count your partials.
What if you can't divide it by 2 either way?
Then you have a decimal.
I didn't.
And once we have the partials, what do we do with them?
Divided by
Divided by 2. Why are we dividing them by 2?
in case it can be a whole.
Right. We're looking at it as if we could take 2 partials and put them together to make a whole, right? So we're taking almost an average,
Which is 18.
which is 18 for me. You guys are probably 18, 20-ish.
I got 28.
I got 36.
Well, I mean for your halves.
Oh, yeah.
All right.
I got 28.
So once we have partials and the wholes, what do we do? Add. So take your whole squares, add them to the partials divided by 2. So I have 48. You are probably like 45 to 52-ish. And after we added them together, what was the next thing that we did?
Divide
Multiply it by the area of the square. 1 kilometer squared. So I have 48 kilometers squared.
I have 42, but I have 33 and 15.
Okay. All right, so what was this that we just found here? This 48 represents what?
Base.
The base of the shape. This is a lake. All right, so do we want just the area? What do we want? Volume. So we find volume by doing what? Base times the height. What is our base?
48.
Mine's 48. Yours is close to that, right?
39.
Okay. So take your base, multiply it by, what's the height?
40. No.
40 what?
Meters.
And we found our area in what units? Kilometers. So do we need to change something?
Yeah.
Okay. So this 40, we're told that the depth of the lake is 40. That's the same thing as our height. And how many kilometers is that? 0.4?
0.001.
We were given in meters, right?
Yeah.
And we're moving how many? 3 to the 1, 2, 3. So we move it 1, 2, 3. 0.04 kilometers. So multiply 0.04 kilometers, and we have a volume of what are you guys getting?
1.92.
Okay. So you should be close to 1.92 kilometers. What? Cubed. All right. So our volume.
Do you have any silver painted markers?
No. 1.92 kilometers cubed. When we're measuring volume, and it's in the liquid form, it usually is displayed in what units? Liters. Okay. So can we change our kilometers cubed to get them into liters?
Yeah.
How would we do that? We can change kilometers to what in our 3D chart? What can we change kilometers to? We can change it to decimeters. And decimeters has what relationship with liters? They're the same. All right. So we can change the kilo to the deci. How many movements is that?
4.
But because our units are cubed, we need to move our decimal
No.
12. So move your decimal 12 places. All right, so this is cubic decimeters, and you guys said that they're equivalent to cubic liters. I'm sorry, not cubic liters, liters. So 1,920,000,000,000,000 liters. The average person in this town uses 350 liters of water per day. So how much water are they using altogether?
624,000 times 3.
Yep. 624,000 people are using 350 liters of water per day. Right here, 624,000 are using 350 liters of water per day. So what does that give us? Yes, a lot. Can I have an exact number?
How's that calculated? Actually, it's a 6, 2, 4, 0, 0, 0, 0, 0. You gotta repeat that for her. 5.
I didn't get the same number.
Come on.
Keith, what are you getting? 624,000.
Times 350 2184000.
Oh, yeah. What's times 350? Oh, Keith said 250 out loud.
And this is liters used per day. Because we were told that there are 624,000 people, and there are 350 liters of water. All right, if the lake is not replenished, how long will the water last? So how much water do we have? Okay. And how much are we using per day?
21840.
Are we going to subtract it? Why would I divide it?
It'll
See how many times it goes into it. So I have
It's
1,920,000,000,000
it's like 8.
divided by 218,400,000
It's
liters.
8. It's like 8.12. 8,000. I got 8.
8,791.
I got
And what units is this?
days.
It is days. Because this is how much we're using per day. And if you wanted to determine the number of years, what would you do?
360.
Oh, divided by 360.
It'll last
Would you buy it?
24 years.
Okay. So are they good on water for a little while?
No.
No.
No? They've got a quarter of a century to live, right?